You check your weather app, it says sunny, you leave the umbrella at home, and 5 minutes later, boom, a downpour soaks you to the bone. Sound familiar? You're not alone. But have you ever wondered, why do weather forecasts still go wrong in 2025? With satellites, AI, and supercomputers, shouldn't we be able to predict rain like clockwork? Weather forecasting has come a long way from sailors watching clouds or farmers reading almanacs. Today, we rely on massive computer models and a global network of sensors to predict the future state of the atmosphere. Yet, forecasts still miss the mark, sometimes slightly, sometimes spectacularly. Let's explore why. Reason 1. Chaos. The atmosphere is one of the most complex systems on Earth. It's governed by the laws of physics, mainly thermodynamics and fluid dynamics, but behaves chaotically. That means tiny differences in starting conditions can lead to dramatically different outcomes. This is known as the butterfly effect. A butterfly flaps its wings in Brazil, and it changes the storm track in Texas. So even the most accurate models struggle when the system itself is inherently unpredictable over long periods. Reason 2, we don't know everything, yet. To predict tomorrow's weather, we need to know today's weather with incredible detail. Temperature, pressure, humidity, wind speed, at thousands of altitudes, across every point on Earth. But we don't. Even with satellites, weather balloons, and radar, there are still gaps, especially over oceans, remote regions, and in the upper atmosphere. These blind spots introduce errors in the starting conditions for weather models, and those errors grow with time. Reason 3, our models are powerful, but not perfect. Numerical weather prediction, or NWP, is the heart of modern forecasting. It solves equations that describe how air moves, how clouds form, how heat transfers, all on a giant 3D grid covering the Earth. But the grid isn't infinitely fine. In most models, each block represents an area 10 to 25 kilometers wide and maybe 1 kilometer thick. That means smaller scale phenomena like thunderstorms, turbulence, or sea breezes often fall through the cracks or have to be approximated. This is called parameterization, and it's a major source of forecast error. Even more confusing? Different weather models give different answers. The US uses the GFS model, Europe uses ECMWF. There's also UK Met, ICON, HRR, and others, each with different algorithms, assumptions, and update frequencies. Forecasters often have to compare them, look at ensemble runs, multiple simulations with slightly different conditions, and then make judgment calls. It's not always straightforward, so that sunny forecast might have been one possible scenario, not a certainty. Accuracy also depends on how far ahead you're trying to predict. One-day forecasts are now about 90–95% accurate. 3-day forecasts are around 85% accurate. 7-day forecasts are closer to 70%. Beyond 10 days, accuracy drops dramatically. Why? Because those small initial errors, remember the butterfly, get amplified with time. This is why long-range forecasts are often useful for general trends, but not for specific timing or rainfall amounts. The good news? Forecasting is improving, thanks to better data and more powerful models. The ECMWF in Europe and the US GFS have both gone through major upgrades. Supercomputers now run at petaflop speeds, enabling higher resolution models. AI and machine learning are being trained to correct model biases and even predict short-term weather directly from radar and satellite data. For example, Google's GraphCast uses deep learning to outperform traditional models in some mid-range forecasts. These innovations help predict hurricanes, floods, and heat waves more reliably, saving lives. Can we ever achieve a 100% perfect weather forecast? Sadly, probably not. Because of the chaotic nature of the atmosphere and the limitations of observations and computing, there is a fundamental barrier to long-term deterministic forecasts. But we can still improve probabilistic forecasts, build better early warning systems, and make climate-aware decisions based on trends. Let's not forget, behind every forecast is a human forecaster making judgment calls. They balance data, models, intuition, and communication. So the next time the forecast is off by a few hours or millimeters, remember, it's not just science, it's art too. Want better forecasts for your day? Use multiple sources. Check your local meteorological service and radar apps. Learn to read short-range trends rather than obsess over 10-day forecasts, and understand that uncertainty is built in, especially with fast-changing conditions like pop-up thunderstorms. So why do forecasts go wrong? The atmosphere is chaotic, our data has gaps, models have limits, and interpretation involves judgment. But forecasts are also getting smarter, faster, and more reliable, with the help of AI, new satellites, and better observations. If you learned something new today about how weather prediction works, or why it sometimes doesn't, give this video a thumbs up, follow our channel for more explainers, and share it with someone who always blames the weather app. Until next time, stay dry out there.